Hi everyone, and welcome back to another session of ISTQB training Test Automation Engineer certification. So far we have completed 2 modules, and today we will start the third one, which is the generic test automation structure. This module consists of 3 main sections, and the first one is Introduction to gTAA, which we will start today. A test automation engineer, also known as TAE, has the role of designing, developing, implementing, and maintaining the test automation solutions. So first of all, let's have a look at that. What is a test automation solution? So a test automation solution is a combination of components to implement a specific test automation task. So if there is a project and there are few tasks which we need to automate for testing, then the first thing which we will come up with is a test automation solutions. As the name suggests, a solution for doing a task. So these components may include any test tool, test automation framework, which we will cover later, or test hardware. So now we know that what is a test automation solution. So now as we develop each solution, there are some tasks which are similar to each other, which needs to be done every time, because we are talking about test automation solutions. So maybe there are several tasks which needs to be developed in the same way, and there are a few questions which are the same questions, and they need to be answered, and there are similar issues which needs to be addressed and prioritized. So these steps and approaches which are reoccurring in automating testing, they become the basis of the generic test automation architecture, which is also known as gTAA. gTAA is the representation of the layers, components, and interfaces of a test automation architecture, allowing a structured and modular approach to implement test automation. So if you are familiar with the concepts of programming, then there is a modular approach to programming and also a structured. So in modular, what happens that your program is splitted into different independent modules, which are actually independent function units, which can be called independently, which can call each other as well. So they are based on different functions. So if there is a project where there are different functionalities, let's say login and maybe checkout, etc. So each functional unit will have its own module, while in a structured approach there are subprograms and there are control flow statements like if then else. So it's like a proper structured, and it consists of sequences, control flow statements, etc. So gTAA consists of both of these approaches. So we can say that the gTAA presents the layers, components, and interfaces of a generic test automation architecture, which are then further redefined into the TAA, test automation architecture, for a specific test automation solution. So this is the hierarchy for each test automation solution, which is specific to a task. There would be a parent, which will be test automation architecture, and all the different test automation architectures will have one parent, which is gTAA, generic test automation architecture. So I hope that this part is clear. gTAA allows for a structured and modular approach, which we have already covered, to building a test solution by defining the concept space, layers, services, and interfaces of a test automation solution to enable the realization of test automation solutions by in-house as well as by externally developed components. Okay, so when we develop several components, so let's say there is a project and there are few components for that project which are developed in-house. So maybe one functionality or few functionalities are developed in-house, but there might be a specific part, few components which were outsourced to another company. They were outsourced externally to a third party and they developed those components. So it might be the case that the test automation solution which we came up with for our in-house components, in-house developed components, needs to be different from the externally one. So we might end up with multiple test automation solutions. So that's where gTAA helps. Supporting simplified components for the effective and efficient development of test automation. So gTAA allows that as well. That's another feature. Right. So we already covered what do we mean by effective and efficient earlier. I think it was in module 2. So effective means that we are testing the right areas and we are finding critical bugs, while efficient means that without taking too much effort. So we are talking about that gTAA is supporting a simplified components so that we are coming up with the effective and efficient development of test automation. The third one is reusing test automation components for different or evolving test automation solutions for software product lines and families and across software technologies and tools. Okay, so there can be multiple test automation solutions. So whenever we are talking about different test automation solutions, or maybe we are expanding them, so there can be many reusable test automation components as well, which can be useful. Easing the maintenance and evolution of test automation solution. So whenever a test automation solution expands, one of the issue is that it's difficult to maintain because it starts getting complicated. So if we have a gTAA, a generic test automation architecture, then it eases the maintenance and evolution of test automation solutions. Defining the essential features for a user of a test automation solution. Okay, so each user of a test automation solution, what are the essential features required for that user, or maybe multiple users, that needs those are defined in gTAA as well. Okay, moving on. A test automation solution consists of the test environment and its artifacts. So when we talk about the artifacts of test environment, it can include maybe something like test environment information, configuration, migration procedures, etc. All these are the artifacts of test environment, plus the test suites. So test suites is a set of test cases including test data. Okay, so now this part is covered, that what test automation solution consists of. Right. Now let's talk about the test automation framework known as TAF. A test automation framework can be used to implement a test automation solution. So it provides support for the implementation of the test environment and provides tools, test harness, or supporting libraries. So this is how test automation framework and is linked to test automation solution. So there is a very common problem when we come across that most of the time whenever we come up with test automation, then the first thing which we think about is test automation framework rather than test automation solution. You must have seen that we pay a lot of emphasis on the test automation frameworks, which is not the right thing, because the first thing should be test automation solution, and then after that, yes, they can be we can talk about test automation framework. The problem with concentrating solely on test automation framework is that, let's say if we have a problem and or maybe a task and we need to automate that, and we have come up with a test automation framework, then what we do, that we try to keep on stretching that test automation framework for adding all the new functionalities. So if we have a problem, instead of thinking that how we can automate that task, we start thinking that how we can expand our test automation framework to fit in the automation of that task, which is not the right thing to do. It is just like that there is a small car and we are trying to fit in maybe 10 people in it. So maybe at the end you are able to fit in 10 people in a small car, but of course that will not be the ideal case. That will not be comfortable for everyone. So whenever you have a task, think that what is the solution, that how we can automate this task, and then think about the test automation framework. So test automation framework is basically for the support of test automation solution. Sorry, test automation framework. Yeah, that's, I thought I said the other way around. All right. Okay, so moving on. It is recommended that test automation architecture of a test automation solution complies with the following principles that support easy development, evolution, and maintenance of the test automation solution. Okay, so these are the 5 principles, which are also known as SOLID, and SOLID is an acronym for the first 5 object-oriented design principles. So if you are familiar with object-oriented design principles, then if you have already worked on object-oriented programming, then you must be aware of these principles, and if not, then I would highly recommend that you search this acronym and thoroughly go through all these 5 principles, because in object-oriented programming, when we talk about when we use inheritance, polymorphism, etc., this is all it's about. So these are the basic first 5 principles for the OOD. Okay, so over here I will not go into the detail of all these, because this is not part of the syllabus. Of course, the part of the syllabus is only that how gTAA, the test automation architecture, follow these principles. But of course, if you are not familiar with these principles, that I would highly recommend that you take it offline and you search these principles. Right, okay, so the first one, which is also referred as S, this is the single responsibility principle. So it says that every test automation solution component must have a single responsibility which must be encapsulated entirely in the component. So in other words, every component of a test automation solution should be in charge of exactly one thing. For example, generating keywords or data, creating test scenarios, executing test cases, logging results, or generating execution reports. The next one is O. So this O basically refers to the open-closed principle by B. Meyer, and it's also known as extension. It says that every test automation solution component must be open for extension but closed for modification. So this principle means that it should be possible to modify or enrich the behavior of the components without breaking the backward compatible functionality. So this is where whenever we write the code, we need to refactor code in a way that whenever there is a new requirement, we can extend the code without modifying the existing code again and again. Okay. Then the third one is referred as L. L is for Liskov substitution principle, also known as replacement. So it says that every test automation component must be replaceable without affecting the overall behavior of the test automation solution. The component can be replaced by one or more substituting components, but the exhibited behavior must be the same. The fourth one is I, and I means interface segregation principle, also known as component segregation. It's better to have more specific components than a journal multi-purpose component. So instead of having one component which is multi-purpose, so it's better to have specific components, maybe for different interfaces for different components. This makes substitution and maintenance easier by eliminating unnecessary dependencies. So if we are following all these principles, so these basically help to expand the solution and also the architecture, and also helps with the maintenance as well. The last one, which refers as D, is the dependency inversion principle. So it says that the components of a test automation solution must depend on abstractions rather than on low-level details. In other words, the components should not depend on specific automated test scenarios. Okay, so these are the principles which the TAA of a TAS complies with. Okay, so if you are already doing programming and you have done object-oriented programming and you are already aware of this these design principles, it's really good. But if you are new to these, you have never used them before, I would strongly recommend that before proceeding further, please take it offline, search these principles, try to understand it, and try to understand with different examples so that you are very clear about these concepts. Otherwise it will be a problem when later on you are when you are coming up with the test automation architecture. So it will be helpful if you are familiar with these concepts thoroughly. Okay, so there are few more things about the generic test automation architecture. So typically a test automation solution which is based on the gTAA will be implemented by a set of tools, their plugins and or components, right? Then the second one is, it is important to note that the gTAA is vendor neutral. It does not predefine any concrete method, technology, or tool for the realization of a TAS. Okay, so if we are talking about a generic test automation architecture, then it is vendor neutral, means that it doesn't require that each tool or technology needs to be coming from the same vendor. So it can be like a combination of different tools, different technologies, and which can be coming from different vendors as well, different suppliers. So so that's why it's referred as vendor neutral. The gTAA can be implemented by any software engineering approach, for example, structured, object-oriented, service-oriented, model-driven, as well as by any software technologies and tools. So yeah, it's clear that gTAA can be implemented by using any software engineering approach. It's not restricted to any specific one. In fact, a test automation solution is often implemented using the off-shelf tools, but will typically need additional system under test specific additions and or adaptations. Yeah. So you must have seen that there are different companies who provide their own the custom-made test automation solution. Sometimes they make it specifically for a specific company, but most of the time they sell it as a product, as an off-shelf tool. So let's say if you have a project and maybe that off-the-shelf tool is providing you, let's say, 80% of what you are looking for. So yeah, that's not bad. You can take that off the shelf tool, and then you can add other things which are required in the system. You can add that, you can extend that tool to your own needs. Other guidelines and reference models relating to test automation solutions are software engineering standards for the selected SDLC, programming technologies, formatting standards, etc. Okay, so these are like few guidelines and reference models which are related to test automation solutions, so which are very specific, like the ones, the engineering standards which we have for SDLC and for different programming technologies, formatting standards. So these all apply to the test automation solutions as well. It is not in the scope of this syllabus to teach software engineering in general. However, a test automation engineer is expected to have skills, experience, and expertise in software engineering. So this is something which applies not to only the test automation engineer, but even if someone is doing manual testing, for that person as well, the knowledge and the expertise of software engineering is mandatory, because otherwise you can never come up with a good solution for automation, or even for the for manual testing as well. You need to have those basic things covered for software engineering. Furthermore, a test automation engineer needs to be aware of industry coding and documentation standards and best practices to make use of them. Yeah, exactly. So the coding standards, which are the industry coding standards and the industry standards for documentation. So the same coding standards which developers use, a TAE needs the same coding standards as well. TAE needs to follow those coding standards and the documentation standards as well. So it applies to in a similar way to a test automation engineer as well. While developing a test automation solution, these practices can increase maintainability, reliability, and security of the test automation solution. Such standards are typically domain specific. So these practices which we have mentioned above, these increase maintainability, reliability, and security of the test automation solution, and such standards are typically domain specific. So popular standards, there can be many other standards, but there are few popular standards which are included as part of the syllabus, which are MISRA for C or C++, JSF coding standard for C++, and AUTOSAR rules for MathWorks, MATLAB / Simulink. So there are many other industry standards, but these are the popular ones, and these are the part of this syllabus which are being mentioned. So so yeah, just go through these ones. So you don't need to memorize all the different coding standards, etc. as well. So it's just that you need to be aware of that what are required for, like, they are a test automation engineer needs to follow all these standards. So with this, we have come to the end of our today's session. So generic test automation architecture is a quite lengthy modules, and this is just a part of it which we have covered today, because there is a lot to absorb. So in one session I don't want to include a lot of stuff. So please go through the things which we have covered today, and in the next session I will cover the overview of the gTAA, which will include the different layers of gTAA. So I hope you have enjoyed today's session, and I will see you in the next one. Till then, take care. Bye.